Welcome back to Workshop Wasteland for part 4 of our 6-cycle oddball series. Today we are machining the cylinder, and I printed out the page out of the book to show you. We're going to take a piece of steel, very similar to this, and turn it into this finished cylinder. Kinda disappointing. I don't know what went wrong, but as you can see, this ring right here is very thin, and the space right here is kind of thick, or kind of wide rather, in comparison to the others. I felt like I did all the math correctly. I don't really know exactly what happened. Maybe I was trying to feed my parting blade too fast. I did have that much stick out, so maybe it flexed a little bit. It kind of looks like whenever you're looking at these cuts that they have a bit of a taper to them, so I do kind of think maybe the parting blade flexed, or maybe I didn't have the vice jaws tight enough and it moved a little bit in the chuck of the lathe. Either way, kind of is what it is. If I hate it enough, I'll remake it, but it was kind of a lot of work. I think it's about a 30-minute video, so, kind of a lot of work to make it. I don't really want to do it again, but if I get to the point that I hate it, I will make it again. But I wanted to give a quick shout out. This is Winky's Workshop here on YouTube. This is his parting blade design. It's kind of based off of the old Atlas parting tools. It has this slit right here cut in it to allow a bit of a spring or a flex to this blade. And I have to say, this thing works absolutely awesome. I'm really glad I stumbled across this video. I basically instantly subscribed. He has a ton of really, really awesome information, tons of little DIY projects, and a really cool workshop. And his videos are very informative. So if you're not subscribed, I'll put the link down in the video description. I don't know how to put it into the video, or I would, but I'll put it down in the video description. I'd recommend checking it out. Maybe subscribe or like some of his videos, but like I said, this thing works great. Sometime I'll make a demonstration video about this specifically. Don't want to take anything away from him. I like to give credit where it's due. So I guess without further ado, let's hop over to the lathe and get this thing going. Alright, so in the element of saving time, I've already turned this down. It's supposed to be 1.5 inches. And I blued it up after the fact, so I don't know how well you can see that micrometer. But it's 1 thou over, which is from the bluing. And I wanted to bore the hole for the cylinder, or for the piston rather, in from this end, so I purposely left it a little bit long. It's currently sitting at 420, and it's supposed to be 1330 seconds, which is 406. So what we're going to do is face this off down to my 406, which means we need to take 14 thousandths off. So run this in until it just kisses that part, which is right there. And then I'm going to slide my indicator over. As you can see, that's on 90 right now, so let's take a 5 thou depth of cut at a time so we get a really nice surface finish here. And I guess I didn't say, I wanted to leave this to turn off of it so that the bore is very square to this cut, because this is where it mounts to the base of the engine. So I obviously want this to be square. So that's 5. This is 10 thou off. I think I'm actually going to speed this up a little bit for this final cut. Which needs to be 4 thousandths. That surface finish probably looks worse in the camera than what it actually is. So the next operation then is, of course, boring this out. I bought one of these, I think it's an end mill holder. It's a MT2 taper down here for my tailstock, and it holds a small end mill. And I like using it because it feels really rigid in my tailstock. So this is going to be a whole lot of drilling. I'm going to first drill through with a 1/4 inch bit. I think this one's pretty sharp. Hopefully sharp enough. And we want to drill this kind of slow because we need this hole to stay pretty square as we go through, which is going to be very important, obviously, for the piston to travel square. Slow this down a little bit. See how sharp this bit is. I'm not going to bore you to death drilling all the way through this. This 1144 steel drill is really nice. I hope I can get a nice surface finish with the boring bar. Okay, I got this drilled out with my largest drill bit that I have, which was a 21/32, which is a 653, and we need to go to 3/4, which is 750. So see how this bores, see how straight we drilled. This is a lot of stick out for this boring bar, but there's not really any other way around it, honestly. Take light cuts to hopefully get this dialed in right. Drop some coolant down in there. See how this cuts on this first cut. That'll tell us really kind of how straight this drilled. If the tool pressure increases a lot, then we know we didn't drill very straight. But hopefully it is indeed drilled straight. That would be great. I stepped up in drill bit sizes, and that really seems to help things drill and bore more square or more straight. So far it doesn't really sound like the tool pressure changed at all, so that's good. I'd say it bored pretty straight. This is going to be kind of a long process boring this out. I want to go slow, try and maintain that square consistency as much as I can, because like I said, this is now squared off of that edge, and or off of that end rather, and I'd like to keep it that way if I could. So I'm not going to show you every boring operation here because, well, it'd be boring. So let me go ahead and stop this for now. I'll bring you back whenever we're closer to finished dimension. Alright, just wanted to bring you back here, show you this boring operation. Got the boring bar in here. Like I said, this is a lot of stick out. It wanted to chatter a lot, so what I did, and it really helped, was, as you can see right back here, right there, I stuck some magnets on the end of the boring bar. I don't know why that helps, but it does. It's currently at 740. We're shooting for 750, or 3/4 of an inch. What I'm going to do here is take off 5/1000ths, and then I'm going to do a couple of spring passes just to get it perfect, and then measure it and see what I need to take off to get to final dimension. This is of course the cylinder bore, so if I blow the dimension by a little bit, which I don't think I will, but if it happens to be a bit too big, then I of course just make the piston and piston rings fit it, so it's not the end of the world. But obviously I want to try my best not to blow the dimension. I personally like making things as close to the plans as I can. I know this isn't for anybody else, or, you know, I also know that I'm not getting paid for this or anything, but if you take your time, you can usually do pretty good. Put a little bit of cutting oil in there. See how this cut goes. Like I said, this is only a 5 thou depth of cut, or 2.5 thou rather, so it's taking 5 thou out of the diameter, because of course in a lathe you're spinning apart, so you're taking 2.5 thou off all sides. So we're going to try and get bang on 750. No guarantees I'll exactly hit that dimension, but like I said, I'm going to try. So this is, like I said, a pretty boring operation, both figuratively and literally, but with this much tool sticking out, if I go any faster with the spindle speed, it really wanted to chatter, so this has given me an absolutely beautiful finish. When I'm all done, I'll get you a nice close-up with the camera and show you just how good it is, but man, it's beautiful. Like I said earlier, this 1144 steel is really nice. Just in case anybody cares, going in and out of this part was about 6 minutes and 30 seconds to go in and back out at that feed rate. So as you can see, this is a slow, tedious process, but I'm going to get this measured up and finish it up if it needs anything, and bring you back whenever we cut these grooves into the cylinder. Okay, well, that is our bored hole right there. And I just love it when something goes perfectly according to plan. However, this did not. When I was boring this out, I didn't take into account that chips would pile up in the back. I thought I was keeping them clear, but apparently I wasn't. And it absolutely gave a trash surface finish in the back half of that. And I didn't notice it until it was too late. So what I did is turned this up to 762 instead of 750, and I went to 762 because the piston that we're going to machine to fit this is 2 thou under bore size, so I figured why not just make this 2 thou over, that way I can make my piston 760. You probably can't see real great in there. Trust me, it's a pretty good surface finish. I'm happy with it. I do have one small score right here, but I think the rings will seat to that just fine when the time comes. But what I did to overcome the chip problem is I came over here to the back of my lathe and I put my vacuum cleaner nozzle right here. This spindle, of course, is a through spindle or a hollow spindle, and this way I could just suck the chips out and prevent them from piling up here in the part. So unfortunately that happened, made me blow the dimension that the plans call for, but luckily I'm turning the piston to fit it, so it's not really a big deal. Let me go ahead and get you set up so we can turn these rings that get turned down on that, and we're going to use a parting blade for that. Okay, so swapped in the parting blade. I'm touching off on this edge of the piece right here, and this is an 1/8 inch thick parting blade. So what we need to do is come over to our indicator and get us a 0 starting point here, and then back away from the part and come over 125, because that's how thick our parting blade is. 1/8 inch is 125. Then come back to 0. Now we need to leave 5/32 left here. So right now this edge of the parting blade is exactly the same as this edge of the part. So we need to leave 5/32 of an inch, which is 156. So we need to come over 156. And I'm going to lock that down. And now we need to leave a 1 inch diameter, and we're at 1.5, so we need to take a lot out of that actually. Yeah, 1 inch diameter, and we're currently 1.5 inches diameter. So we need to take 500 thou out of that. I need to slow down my lathe. I got my lathe in back gear. Hopefully it's not too noisy for the camera, but what we're going to do here is just touch off. So that's a touch off, and we're at 25. So we need to go around 5 times. Alright, so that's around 1 time. That should have taken off 200 thousandths. Let me measure that. I feel like I'm confusing myself right now. Yeah, so that took off 200, okay. So we need to go around 1.5 more times, but I'm going to take this incrementally. So this needs to be a gap 5/16 wide, and 5/16 is 312. But since we have an 1/8 inch thick parting blade, we need to do 312 minus 125. That means we need to move over 187 from here. Be nice if I stopped hitting that camera. So I'm going to put this back on 0. And then we need to move over 187. So 187. Take a cut there. We'll do the same thing. over and cut this center out. Now we can come back to our 0. Alright, I'm going to take a quick measurement on that, see where we are. I think, as you can see, anybody who's been a machinist or has a small, you know, Asian import lathe, or even this like 9-inch South Bend, as you can see, that parting blade just works awesome. Winky gave an awesome suggestion there. Alright, so we're going for a 1-inch diameter. We're currently at 1 inch, 109 thousandths. So we need to go around one more time. Or actually, we need to go 50 thou depth of cut more. I'm glad I thought about that before I went around the whole time. So I'm probably going to time lapse this a bit. Okay, that is our groove. Should be right handy to 1 inch. Yeah, pretty much dead on the money. Okay, so now what we need to do is leave a 1/16 of an inch for a whole bunch of grooves. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 grooves. So we'll cut as many as we can till we have to flip this part around. Alright, so we're going to indicate off of this side of this slot. So I'm back at 187. I need to back out. We're going to come to down here to a 0 point. Now we need to go 125 again for the thickness of our blade. We'll zero again. And like I said, we're supposed to leave them 1/16 of an inch. And 1/16 is 62.5 thousandths. So 62, and we're going to guess at the half because that's close enough. These are really just a cosmetic thing. And then for these, looks like we leave an 1.25" diameter. So 1.250, which means we need to take 250 off. Alright, so we need to take 250 off. That should be that groove. Calipers don't quite fit in there, but it looks like that's it. And then this is supposed to be 62. How do we do? Seems like we missed that dimension just a little. Not exactly sure how. It's like 64, 65 thousandths, which is just simply good enough. Alright, so let's think about this rationally now. We need to move over again 125. From there, 0 again, and go 62.5. Okay, I think this is a good point to kind of cut the video. I'm going to cut as many of these grooves as I can, like I said, and flip the part around, get the rest cut. This is literally just rinse and repeat 9 times. Not really a whole lot else to show you on this part, but that's pretty much it for this. Well, like I said in the beginning of the video, kind of disappointed in myself that I screwed this up. Wish I knew what went wrong so I wouldn't make the same mistake in the future. I may or may not remake this cylinder. The good news is there's about a 1/2 thou taper, so that's easy to lap out with a little wooden lap. There's other videos all over YouTube about that. I may or may not remake this, I don't know. I really hate it, but I can probably live with it. So thanks for sticking around to the end of the video. I know it's a long one, but like I said before, I like to show you as much as I can. If you liked what you saw, please click the like button. If you want to help me out, go ahead and subscribe. Otherwise, have a wonderful night.